Hi folks, this is Calc 3, Quiz 15. We're asked to find the area of the portion of a paraboloid which lies above a given region. So, the key word here is area. And so to find the surface area of something, we need to integrate over a region R, the surface area differential. So, if we look at the surface, it's our nice happy-go-lucky paraboloid that we've grown to love. That's him there. And we're in for a pleasant surprise. We're actually told the region over which we're integrating. So the region R, that's going to be a disk centered at the origin with a radius of 3. So that's our region R. So if I draw that in the XY plane, I get a perfectly good region suited for polar coordinates. The angle theta is between 0 and 2 pi, and the radius is 3. So that's going to be our region R. For the surface area differential, I need to evaluate that. So since we have z as a function of x and y, the surface area formula looks like this: 1 plus zx squared plus zy squared dA, which is 1 plus the zx is 2x, the zy is 2y dA, and so I get this. Since I want to convert it to polar coordinates, because the region is easier in polar coordinates, I'll convert this into polar coordinates. So what do I get? Well, 1 plus 4x squared plus 4y squared is 4r squared, and remember the dA is r d theta. So for my surface integral, or my, surface area S, I'm going to integrate theta from 0 to 2 pi. I'm going to integrate r from 0 to 3. I have r times the square root 1 plus 4r squared dr d theta. So that's the integral I have to evaluate to give me the surface area. Alright, so there's that integral. I'm going to look for a u substitution because the derivative of the inside of the radical is sitting right out here to help me. So I'm going to let u be 1 plus 4r squared. So du is 8r dr. I have 1r dr. I can take care of the 8. I can multiply the inside by 8. I'll factor an 8 out front, and I might as well take it all the way out front. Do that. Since it's a definite integral, we'll convert the limits of integration. When r equals 0, u equals 1 plus 4 times 0 squared. When r equals 3, u equals 1 plus 4 times 3 squared. And so I get the 1/8 integral 0 to 2 pi, integral 1 to 37, square root u du d theta. That's 1/8 integral 0 to 2 pi. The antiderivative of u to the 1/2 is 2/3 u to the 3/2. This is evaluated from u equals 1, u equals 37 d theta. This is 1/8 integral 0 to 2 pi. I get some horrible constant in here. I get 2 times 37 to the 3/2 over 3 minus 2/3 d theta. And so let's see what I can do here. The integral 0 to 2 pi constant d theta, I'm just going to be multiplying this by 2 pi. 2 pi times 1/8 is pi over 4. I'm going to multiply that. I'm going to have a pi over 12 times 37 radical 37 wait a minute, I can factor another 2 out. Make that pi over 6. Radical 37 minus 1. So that's the actual surface area of that paraboloid. So that'll do it then for number 1.